problem, you want to solve a problem, draw a diagram. So I see a few of you, you wrote down your let statements, but unless you have a diagram, believe me, it helps you visually see it a lot better. My guess is if I gave you a question that just had a diagram and just said solve this, you'd probably do that a lot better if I just pose it as words. Okay? So half the battle for some of us is actually taking the words that we have, transposing onto a diagram. Okay? So what kind of triangle do we have here? Right angle, right? So that means it has a 90-degree angle. Now why do you think we're picking a triangle like this? What special properties does a right angle triangle have? What special properties does a right angle triangle have? Going back to like grade 8 even, grade 9. The sides of the triangle, right angle triangle. Remember the special qualities?
Pythagorean theorem applies to it?
Okay, because it's a right angle, so what's the Pythagorean theorem? Right?
Yeah.
So we have the sides, A, B, and C, right? With C being the hypotenuse, or the side that's opposite the 90-degree angle. We have A squared plus B squared. So we squared A and B, the sum of that is going to equal to C squared. Okay? Very famous algorithm, formula, however you want to call it, discovery. Something that should be always in our heads. Okay, so we have one side that is shorter than the other leg. So we're talking about basically these sides. They're referred to as a leg. Okay? Call them length. It's not hypotenuse. The other length, the other side has a special length, special name for a ring. Okay? So what might be your let statement be? Let X.
Represent A.
I'm going to say S. I don't like X. I don't want to use X all the time. Let's get out of the habit of using X all the time. Let X equals length of the shorter leg, the longer leg, the longer leg.
B.
Okay. So let's go back into our diagram and let's just say that we'll pick that one to be X. Right? So what would be the length of the other sides then?
You mean S?
Oh, sorry. I mean S. Thank you, Jenny. So how can we express the other sides? How can we express the other sides? Katie? Wanna try?
Let.
Well, what might B be? What's the length of B?
The shorter side?
Oh, actually, if I make a diagram from yeah, B should be S, right? That's the longer side. So what will be AB?
I don't know, like A, C?
Well, relative to S, what do we know about it?
It's the shorter,
Yes, how much shorter?
1 centimeter.
Yeah, it's 1 centimeter shorter. So that side could just be S minus 1. What do you know about the hypotenuse? Okay. Sorry, how much? 8 centimeters. So here would be S plus 8. So here we've defined or labeled our sides of our triangle relative to this one side that we know. We don't know S. But we know the other two sides are relative to this one side. We're given information about it. So here we can have, so our equation is, well, we start off with A squared plus B squared is equal to C squared. We understand that relationship. So A here is just S minus 1 squared. B here is S. And it's equal to C squared, which is S plus 8 quantity squared. So now we have an equation. What is it that we want to do for this equation now?
Well, excuse me.
Let's see. Rob?
Simplify, sort of
Okay, well, we can simplify, but what's the purpose of simplifying? What is our goal? Sorry, no?
Find the value of s.
Find the value of s that does what? Like you say s equals 2. Right? How can you expand on that, Nora? Find the value of s that what?
That equals.
A because then you could sub it into the other ones.
But what's the purpose of what value of s? What do we want to find the value of s for? Kenna? Okay, but we're focusing on this equation, right? Finding s will give us the length of the side, yes. But mathematically speaking, what is the goal of finding s? What's the purpose of finding s? Mildred? Find the longer side? Obviously the grade 9 teacher did drill it to your heads. Mo?
You're trying to isolate the variable.
We want, yes, well I said we want to find the value of s that makes this equation true. Right? S equals 2, I know will not make this equation true. Because it will be 2 times, 1 times 4, 1 plus 4 is 5, plus 2 plus 8, which is 10 squared, is 100. S equals 2 will not make this equation true. Okay? So here we want to find the values of s that make this equation true. That's what solving for an equation means. Okay? Doing that in this case will give us the length of side s. Okay? So how can we solve for s here? How can we find the values of s that make this equation true? Trey? We could square root each of them. So we could do something like this. But let me warn you that the square root of that is not equal to x plus 2. Okay? So taking square root of something when we're adding something does not break up nicely. It's the same reason when we had something like x plus 1 quantity squared, or x plus 2 quantity, that does not equal to x squared plus 4. Right? The exponent loss does not apply. Square root is really an exponent. You'll learn that in grade 11. Okay? So the exponent loss, you can't do that nicely over something that's added. Okay? So we might want to try square root it, but it doesn't get us anywhere here because this part here is hard to square root. Okay? Any other guesses? Any other attempts? Okay. Yeah, so let's try to expand it and see if we could group like terms. Let's try to simplify this expression. So it'd be hard for me to erase this square root thing, so I'm going to just erase it all. Write it again. So s squared plus s minus 1 quantity squared is equal to s plus 8 quantity squared. So if I expand this, I got s squared. What's s minus 1 quantity squared? What's that expand to? I'm going to do my shortcut. Remember the shortcut for expanding a binomial squared? Dan?
S squared minus 2s plus 1.
Right, so we get s squared and then negative 1 times s times 2 gives us negative 2s. That was our shortcut. And the negative 1 squared gives us plus 1. So we'll do the same thing here. S squared plus 16s plus 64. Okay? Just took it, we just expanded it. So now we see the purpose of that, all that expanding that we did last unit. Now how can we try to simplify this now? Okay? Yeah, so I could group these two like terms here. I got 2s squared minus 2s plus 1. I could put s squared. I can't do anything on this side. So at least I simplified the left side a little bit. Right, by combining my two s squares to 2s squared. What can I do now? What can I do now? How can I solve for s?
can move all the s's to one side of the equation.
Yes, Marcus?
You can move all the s's to the one. To one
We
side
can
of
move
the
all the s's. So what's the purpose of moving all the s's to the one side?
So you can have all the s's on the other side.
Okay. So what we want to do? We want to move the s squared over?
Yeah.
So we have 2s squared minus s squared. So we're going to subtract s squared from both sides. Then we're going to subtract 16s from both sides. And we still have 1 here. Plus 1 is equal to 64. So now we can simplify even more on the left side. So with s squared minus 18s plus 1 is equal to 64. Guess it's a little bit closer, it looks a little bit more tidy, but how can I still solve for this? How can I still solve for this? Jenny?
Could you leave the terms on either side of the equation and then do process of elimination for like subtracting?
What do you mean by process of
Like
elimination?
what was it? We did three subtract them, so you only have one variable left.
Oh, but here we're only dealing with one variable though. We're only dealing with s. So you think about way back in unit 1. Okay. Well, we had 2 variables, we're solving two linear equations. Yeah, we only have one variable, and one of them is squared. Right, so how do we solve for a variable that's squared? Kenna?
It's just a side question.
Okay.
Does one go onto the other side?
Well, we could put 1 on the other side. But what? How? In order, if we're going to do that, what does that buy us?
What's trinomial?
Sorry?
What's a trinomial?
Well, this is we have a trinomial on the left side. Well,
I don't know if this will give you the answer, but can you just factor it? Can that give you any variables?
so what's the purpose of factoring? What does
I
one
don't
side?
know, I was just throwing
What does
it
one
out
side
there.
have to be for us to purposely
Zero.
try to factor?
Zero.
Yeah, we wanted 0, right? That's one of the tricks that we learned how to solve a quadratic equation. We'll make one side 0, and then we could factor the other side. If each of those factors equals 0, we solve the equation. So here we'll subtract 63 from both sides, 64 from both sides. So we get minus 63 is equal to 0. S squared minus 2s squared minus s squared gives us an s squared. We had 2s squared here. We subtracted s squared from both sides, and then we're left with s squared. So, how are we going to do this? Do you want to factor it?
We do the root.
Pardon?
Do we do like the what's it called? Like the root thing? The I don't know what the formula is called.
The quadratic formula,
Yes.
right? We can use the quadratic formula, we can factor, we can even try to complete the square. 3 different ways to try to solve this equation now, right? Which way you guys want to do it? Factor? Okay, so PSI. So our product is negative 63, sum is negative 18. What 2 numbers multiply to negative 63 to add up to negative 18? So what are factors of 63? Obviously 1 and 63. Well, let's work systematically. 2, does 3 divide to 63?
Yeah.
3, 21. 4, 5, 6, no, 7. 7 and 9. Yeah, so we can see that here, 3, 21, we make the 21 negative. We get negative 21 and 3. So here we can factor this to x. So I want to decompose this. S squared minus 21x plus 3x minus 63 is equal to 0. So here I'm going to factor out 4, something like that, 21x. I'm going to factor out, how do I get x's again? See, I got to stop thinking about x's. S squared minus 21s plus 3s minus 63 is equal to 0. So I'm going to factor out s out of this part, so I get s minus 21. What am I going to factor out here? 3. So s plus 3. Sorry, it's factor out plus 3 and I get s minus 21 is equal to 0. Finally, I get s minus 21 times s plus 3 is equal to 0. So now I have my two factors. And if I set each of them to 0, that's my solution. So s minus 21 is equal to 0. S plus 3 is equal to 0. So therefore s is equal to 21, or s is equal to minus 3. So I've answered the question, I'm done. Right, solve for s.
No, we have to sub it back into that.
Right. Okay. So as we're looking at the some of you guys did, you need to answer the question. So I'm asking you the vertex, don't just give me the y value. So here I need the lengths of the sides of the triangle. So first of all, are both answers acceptable? Both answers make sense for s in this context. No?
No.
How could you say no, Tran?
Because we have s equals minus 3.
Yeah.
Can't have a negative.
We can't have a negative value for a side, right? So we could rule out this as a possible length of a side, right? So therefore s just gives us s equals 21. So therefore, lengths of the sides are 21 centimeters. What's the other two sides? 29 and 20 centimeters. Because we got that back up here because the other side for s minus 1, so 21 minus 1 gives us 20. The other side was s plus 8, 21 plus 8 gives us 29.
What if we did it the other way? The square root thing.
Which way? When we took the square root up here?
No, like at the bottom when you solve it. When you did a plus or minus.
Oh, when you did the quadratic equation?
Yeah.
So quadratic equation, again, you would have came up with the same answers. You would have came up with s equals 21, s equals negative 3. You would have got the same answers using a quadratic equation. If you completed the square, you would have got the same answers. Okay? Any questions on this? No? Do you want me to take up another word problem? Not my favorite thing to do, but if that's what you guys want. Other than that, I give you time to review, do the word problems on your own in preparation for your test on Monday. So next Monday you have a test, your unit test, which is basically what you have for your recent summative. Probably making the questions a little bit more challenging. Same principles though. And the quadratic formula is going to be on there. You never got tested on quadratic formula. So you need to memorize that formula. Right? Minus b plus or minus the square root of b squared minus 4ac all over 2a. And solving problems. Yes, Katie?
When doing the quadratic formula, like how do you go from having the x-intercepts to finding the vertex?
So what, I mean,
Like you
that's,
get
that's regardless of the quadratic equation. That aside, quadratic equation helps us get us the zeros for the x-intercepts. How do you get the vertex from there? Do you not remember in general?
No.
We can help Katie out. So if we're given the two intercepts, how can we find our vertex? Adrian?
Find the axis symmetry.
Yeah, so once we have our zeros, we can find the axis of symmetry, right? Which is the halfway point between those two
But
things.
like how, like if you're just left with those, like, do you sub it back into something?
Well, if we get the axis of symmetry, that's the same as our x coordinate, right, of our vertex. Axis of symmetry is the x coordinate of our vertex. So taking the
If we
half,
know our vertex, how do we know?
so it gives us half of our vertex, right? It gives us the x coordinate at least, right? If we take our roots, find the halfway point, it gives us axis of symmetry. It gives us x value. So how do we get the y value of the vertex afterwards? Dan.
You take the axis symmetry, and then you put it into the 2x value.
Yeah, you just plug.
You just plug into the 2x values, and then
You just plug. Yeah, just plug it back into your original equation. Just get y.
So find the averages between the x-intercepts.
Yes. Average of your roots.
Average your roots.
Average of your roots, or average of your x-intercept.
So not into the quadratic formula, but into the original.
In the original equation, yeah, because that's what that original equation does. It's describing that curve, right? It tells you every single point on that curve. That's the whole idea of the
But how do you
equation.
find the axis of symmetry? Like, let's say you just have like the points.
So you have 2 points. Once you get that, you have 2 values. You use the quadratic formula. You add them together and divide by 2. You get the average of it.
Okay. Thank you.
No?
What's the short form for finding the axis of symmetry in the quadratic formula? Because you showed
Ah, yes, that's right. What was the equation for that?
Oh,
negative.
minus b over 2a.
Yeah, that's
Yeah.
Yeah, so axis of symmetry. Right? That was the other thing that was derived out the quadratic formula. Axis of symmetry you get from minus b over 2a. So this was the other word problem I was thinking about taking up. I'll leave it up to you guys if you want to do it or not.
minus b over 2.
Minus b over 2a. Adrian?
How much harder would it get compared to
Or is this as hard as it gets? No.
I don't know.
No, for the test, just for the test.
Just worry about whether you understand the concepts or not. If you understand the concepts, you'll be fine on the test.
this?
I
Okay.
suck at word problems. Yeah. I don't think everybody's good.
So do you want me to do this together? You want us to do this together?
Just try
Okay. So the path of a basketball after it's we don't throw basketballs, right? Obviously whoever wrote this question does not play basketball. We throw basketballs?
You wouldn't know what that would be. Well, don't you throw it?
It's shot. We throw bricks, which I've seen some people on the basketball team and everything do throw bricks, unfortunately. But most of the time when we shoot a basketball, path of a basketball is shot from a height of 1.5 meters above the ground. It is given by this equation. H is equal to negative 0.25 d squared plus 2d minus 5. So this is the equation that models the path of your basketball. Similar to when you guys were doing the marbles, you guys came up with the equation, right? Your own equation to model the path of your falling marble. So here's the equation that models the path of this ball that's being shot. Okay? Where h is the height in meters and d is the horizontal distance in meters. How far has the ball traveled horizontally? So I'm shooting here, and I shoot the ball like this, follows a parabola. How far away does it hit the ground from me? That's the question. Right? Hopefully you can see that from reading it. Okay? If you're reading this question, I see people doing this. That's fine. Because what you're doing is you're visually trying to figure out what's going on. You're reading the basket. Okay? If that helps you get you thinking, perfectly fine. Right? I'm gonna laugh my head off if all of a sudden I put a basketball question on there. All 20 of you guys are like this at the same time. So how can we figure this? How far has the ball traveled horizontally to the nearest 1/10 of a meter when it hits the ground? How can we try to figure this out? Okay?
Use the quadratic formula.
Okay, what does the quadratic formula help us do though?
Finds the roots.
finds the roots. But how you know we're looking for roots? No, I'm just asking, how do you know we're looking for roots? Sorry? I've told you where to start several times. Where are we going to start? Right here.
You don't know what to.
What are we going to start right here? What are we going to do? Draw a picture. Thank you. So here's my basketball. It's a nice looking shot. Look like that. And then it hits the ground. So we got to draw the ground. So it hits the ground here. Right? Please tell me that this kind of makes sense. Right? Just a simple picture. Right? I suck as an artist. I'm the worst artist in the world. My son, when he was 5, drew better than I did. No.
No,
I'm the worst. No.
If you see Jake's picture of the Hunchback of Notre Dame,
What a great day.
See, my picture of the Hunchback of Notre Dame look like this.
Jake colored out the face, so he got a black paint and blue eyes and a mouth.
That's my Hunchback of Notre Dame. Jake's worse than that. It'd be pretty sad if it were worse than that. Anyways, we digress.
You still have
Man, that's one really good guy.
the net by that
So now we have our picture. How can we start applying?
Do we get marks for drawing pictures?
No.
Marks for
But you'll get marks for getting the question right because you drew the picture. So we're given the ground. What about we just associate the ground with? Yeah, our x-axis, right? Where about we want to put our y-axis? Well, what happens when d is 0 here?
It's on the ground.
What happens when we substitute 0 in for d? What do we get for h?
Y is 0.5.
Well, no, look at the equation. Right? We substitute d in for this. We just get 0 plus 0 plus 1.5. So h is 1.5. Makes sense. He shoots it when his distance is 0. That's 1.5 meters above the ground. So we probably want to do our y-axis here. Right? And this makes sense because this point is 0, 1.5. Okay? So when it hits the ground, what do we notice there? When the ball hits the ground? X is equal to 0? No.
0 something.
X is equal to 0 right here.
Y is equal to 0.
Y is equal to 0. So here we notice that y is equal to 0. Oh! Wow, that's a special attribute again. Y being 0. Now, Jake, why is it we want to find roots? Why is it that we want to use the quadratic equation to find roots?
Find the vertex.
So basically, we want to find when the height is 0. Right? When height is 0, we want to find out when the height is 0. We plug in 0 for h. I should use h here to be more accurate. This should be our h, and this is really d. To simulate what we're talking about. So here we have h is 0. Now what does it look like we're doing? We're solving for a quadratic equation, right? Quadratic equation on one side, 0 on the other. Now we could apply the quadratic formula because we have a quadratic equation. Here's a hint on how you probably know you're going to have to apply the quadratic equation, that I'm not going to factor this. I'm going to complete this by square. To the nearest tenth of a meter, right? In other words, you're going to get some decimal answers. So we get d is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So d is equal to, so what's my a value here? A is what? And negative 0.25. B is 2, and C is 1.5, right? So just show your work, write it out. That way you can plug into the formula easy. So negative B is negative 2 plus or minus the square root of 2 squared minus 4 times A, which is negative 0.25, times C, which is 1.5, all over 2 times negative 0.25. This is why it's a quadratic equation. So D is equal to minus 2 plus or minus the square root of 4. Negative 4 times negative 0.25 gives me a 1 times 1.5, so it's basically adding 1.5 minus divide by negative a half. So here we get D is equal to, I'm going to put over here now, D is equal to minus 2 plus or minus the square root of 5.5 all over negative 0.5. So D is equal to, what's the square root of 5.5? So here's the thing, when you do these calculations, take them to 3 decimal places. And then when your last answer, that's when you leave it to 1/10 of a meter. Okay? So what we call 3 significant digits, I think. It's actually 3 significant digits is 2 decimals actually. Anyways, leave it to 3 decimals. So minus 2 plus or minus 2.345, seriously?
Yeah.
Wow. Negative 0.5. So one value, D is equal to, was negative 2 plus 2.345. That gives me 0.345 divided by negative 0.5. So that gives me 0.7
Wait, how'd you get to that step?
roughly.
The previous one.
Negative 0.7. Sorry, Katie, which step?
How'd you get to the?
This one?
Yeah.
I did the math in my head. Negative 2 plus 2.35 gives me a positive 0.345. So this is like 0.7 stuff. So it gives me a negative 0.7. Yes, Adrian. You can't have a negative, but we have another value to work through here. These also negative 2 minus 2.345 gives me negative 4.345 divided by negative 0.5. So that gives me a positive 8.7 roughly. So here we go again, using quadratic equation, a positive and a negative answer. In this case, we want the positive answer because he's shooting it ahead of him. Not shooting it backwards, right? It's kind of hard to do. Actually, shoot it backwards. So he's shooting it ahead of us, so the answer is going to be positive. So therefore, it fell, or it hit the ground. 8.7 meters away. Okay? So really this is just an application of the quadratic equation.
Wait, when did you get 8.7 after D equals negative 4.35?
Well basically it's negative 4.35 divided by, multiplied by negative 2. Dividing by a half is the same as multiplying by 2.
Right, yeah.
Right?
Yeah.
Bring your calculators to your test. If you don't have one, buy one now. Walmart had one for like $6. I was tempted to like buy like 10 of them. So I'm not spending $60 on calculators that disappear from my anyways. Alright? Get a calculator. You're especially gonna need one for next unit, which is on trade. You need it for the rest of the year, so make sure you bring your calculators. So same question. Find the horizontal distance when the ball is 4.5 meters above the ground. Okay, so same question, but now we want horizontal distance when the ball is 4.5 meters above the ground. How will we solve that? When we go back to our picture, let's take a look. Right, here we're gonna have 4.5, maybe it's up here. Right? So where does the parabola cross that? Sorry, what'd you say there? Well, not quite, because the equation doesn't change, right? Just like the equation for your marble, it stayed the same. You don't change the equation, right? So when I got you to move the cup, did you change your equation? No, the equation stayed the same. So how can I solve for this now, when the ball is 4.5 meters above the ground? How can I find how far away from it? So I shoot it, 4.5 meters maybe is a little bit higher than the ceiling. How do I know where it basically hits the ceiling, crosses the ceiling, if I was to shoot the ball? How can I know it's 4.5 meters high? 4.5 meters high. High.
Wait, is
How do I know when it's 4.5 meters high?
that the highest it goes?
No, it did say that's the highest it goes. Just where the ball is 4.5 meters high. Norm.
Just replace 4.5 with just replace H.
Yeah, we want H 4.5 meters. When is it 4.5 meters high? H tells us how high the ball is. So we just plug in 4.5 into our equation.
Yeah, that's what I did.
Right? Okay, well, kind of a little bit closer. I'm gonna clue what to do now, though.
You bring
What? Say that again, Jack?
bring the 4.5 over.
Okay,
Subtract 4.
thank you. So we're gonna subtract 4 point, because we have a quadratic equation, we can solve for a quadratic equation when it's equal to 0. Right? Same thing as finding the roots. So if we subtract 4.5 from both sides, we can get 0. Negative 0.25d squared plus 2d. Now we're going to have, instead of plus 1.5, we're going to have minus 3. Okay? So it looks like it did change. We did have to change that constant, but it wasn't 4.5. We had to subtract 4.5 from that number. We get negative 3. Now we're going to use. We're going to try to factor this? No. That could be nice, I don't think. Right? So quadratic formula. So d is equal to plus or minus. So d is equal to b, negative b plus or minus the square root of b squared minus 4ac all over 2a. D is equal to minus b, again it's negative 2, plus or minus the square root of 4, so which is 2 squared. So I'm going to do this a little bit in my head. Negative 4 times negative 1/4 again, so give me 1, times the negative 3 is going to give me 1 times the negative 3 is going to give me negative 3. b squared is then positive 1, and c is negative 3 times negative 3, all over 0.5. So d is equal to negative 2 plus or minus the square root of 1. This is working out too easy. I don't believe this. 4 times a quarter gives me 1. So d is equal to minus 2 plus or minus 1 over a half. Divided by negative a half. Is it right? So d is equal to, well, negative 2 plus 1 over 0.5. And d is equal to negative 2 minus 1 over negative 0.5. So here d is equal to negative 1 divided by negative 0.5. So d is going to give me 2 here. 2 times a, 2 times negative a quarter is negative half. Right? So we're still, notice that we're still dividing by the same thing. We're still dividing by negative half. Right? The only thing that changed in here was what we took the square root of. And here d is equal to negative 2 minus 1 is negative 3 divided by negative a half. So d is equal to 6. So therefore, how far was the ball away when it's 4.5 meters then? How far away was the ball away from me? If I shot the ball, how far away from me was it 4.5 meters high? What did the math say?
2 and 6.
Oh, do you?
2 and 6.
The axis is
Yeah.
Well, does it make sense that there's 2 places where it's 4.5 meters away from me?
Yeah, no.
Well, look at our diagram, right? So pretend the roof isn't here, but the roof is around 4.5 meters. If I shot it, it hits 4.5 meters when the ball's going up. So right here, and when it's coming back down, eventually the ball has to come back down,
Right.
it's going to hit 4.5 meters as well, which is going to be right around here. So it makes sense that there's 2 points now, right? When it's going up, it'll be 4.5 meters at some point, and when it's coming down, it's going to be 4.5 meters high at some point as well. So here, it's really you have 2 places. Therefore, at 2 meters away and 6 meters away. Okay? Kind of dry, I know we just plug in a formula. But I just want to see how this relates to, that marble program, that marble thing that we did. So there we were just dealing with the vertex. We knew the vertex. But knowing the vertex allowed you to get you the formula or the equation. Here we give you the equation. Okay, any questions on this? Yes.
I'm just a little confused. Any, I only see C plug there, I don't see A. Like,
Sorry?
I only see 4 minus the value of C.
You talk about this part right here?
Yeah.
So this is 4 times negative 0.525 times negative 3. It's actually negative 4.
Oh, so
So negative 4 times the negative a quarter gives me a positive 1. Negative 3. And here gives me the negative 3. Right, so that 4 minus 3. So this one we probably could have factored. Worked out pretty nice. Puzzle still? The key,
Just
draw your diagram. Once we draw on our diagram, we see that we're just solving for the roots. Right, solving for this equation. And in this case, we just told us to do it with the quadratic formula. Okay? You could use any of the methods, you could complete it as squared, you could have factored. This one just worked out nicely with the quadratic formula because we knew we'd be working with some, especially the first part, working with some messy square roots.
Let's skip the question.
Okay. If I gave you this equation, could you have solved it? If I didn't put it in a word problem, I said solve for 0 equals all we're doing. Just have to put it into context.
Would you recommend just starting off using quadratic equation and not trying to factor in the square because one of them doesn't work and then just replace it?
For this, if it says something again, nearest 10, just go with the quadratic equation, right? Sometimes you get to a word problem where you can see that it's easily factorable. I like factoring and completing the square over quadratic equations because honestly, this is a lot of math. A lot of stuff I can mistype on my calculator, forget a negative sign, simple arithmetic mistakes gonna give you the wrong answer. Alright, whereas factoring, a little bit more straightforward for me. So your preference. If you're a little bit better at that position, then go for a quadratic formula. Let's see that.
So do we need to know this formula? We have to know it. That's like making factoring.
This quadratic formula?
Yeah.
This?
Yeah.
This? Absolutely. You should have done lots of homework on that already.
Will you
So that
give
sort of
us-
equation should be ingrained in your head.
But will you give us options on whether we can use that or yeah, or are there certain-
Solving word problems you can do however you like. When it's a straight out question, like algebraic question, we will ask you to do a certain way. Just sort of like what we did.
But either way, you're gonna end up with the same thing, right?
Yes, but we need to make sure that you can do completing a square,
Okay.
factoring, quadratic formula. Those are the 3 big things of this unit. We gotta make sure that you can do all 3 of them. We need to assess you on all